Hello, and welcome to a video on interacting with NetWitness via the API. If you are writing scripts to extract data from the platform, or even building playbooks in an automation platform, this information will help get you started. I should note that NetWitness does have an automation platform called Orchestrator, and while I would consider some of this information to be a prerequisite to playbook development, we're not covering anything Orchestrator specific in this video. There are actually two APIs we'll be working with today, one for running SDK commands on the core services, and one that we call the NetWitness API for interacting with respond and endpoint services. By the end of the video, it should be more clear to you which API calls you'd need to build use cases, how to structure your queries, and how to interpret query results. I am going to assume that you have a general understanding of how NetWitness works with respect to querying, metadata structure, device types, and some administrative functions. And I'm also assuming that you understand HTTP requests and responses, and have access to an environment where you can run the commands we'll be discussing. We'll mostly be running commands using curl in a Linux environment, so you'll want to make sure that you have that set up. We'll also be using the Postman API platform to demonstrate some concepts. And you'll need properly configured NetWitness user accounts in order to access the APIs. Again, there are two APIs that we're working with today: the Core Services API and the NetWitness API. If you see documentation or hear someone mention the REST API, that is the older name for the Core Services API. You might also see the NetWitness API referred to as the Respond API because it's more common for this to be used with Respond rather than Endpoint. The Core Services API is used for interacting with core services such as the broker or concentrator. Authentication to these services uses the security configuration on each individual service. These accounts are not the same as the ones used to log into the user interface. From the Admin Services page, find a core service where an account needs to be created, and click View Security. If you don't already have an API role created, go to the Roles tab and create a role with the SDK permissions. For the devices in my environment today, I need SDK packets, content, and meta permissions. Next, go to the Users tab and create a user assigned to the role that you created. And if you think you'll be running large queries, consider modifying the core query timeout to something longer than the default. When done, you'll need to replicate the account to all other services, including the broker service where queries will be run against. To test these accounts without having to do any scripting, you can access the API via a separate user interface. Each service has a REST API port, 50103 for brokers, 50105 for concentrators, and so on. So, plug that address into your browser and log in. This is actually a very helpful tool for running one-off commands without needing to script anything, and even more helpful for learning and testing the different features of each API call. When you click on the asterisk next to SDK, you'll see a drop-down menu here. Selecting a method will bring up more information about it, and you can plug in your query and run it here. Moving on, we also need to create an account for the NetWitness API so that we can interact with the Respond database. The account used for this is the same kind as what is used for the typical analyst user interface, so we'll navigate to the Admin Security page, and again we'll need to make a role for API users. This role needs the Integration Server API Access role, and a few of the Respond Server Alert and Incident roles. When done, save the role and create a user assigned to that role. Fortunately, there are no other services that we need to replicate the account to, so we should be all done with our user creation steps now. Next, I would recommend setting up Postman for easier API interaction. You can use any API platform you'd like, but we already have a NetWitness collection built, which only takes a couple minutes to set up. First, go to the Postman website, download the program, and while you're there, also sign up for their free account. Next, go to this NetWitness blog. Download the zip file attached to the bottom of the post and extract it to a folder on your PC. Then simply open up Postman and import that JSON file. The author of the post, Josh Randall, also has a few videos explaining how the APIs work and how to interact with them. If you have any questions after this video ends, definitely go check out Josh's videos here. We'll come back to Postman later. For now, let's talk about the format of a core services API call and how to perform them at the command line. When using curl, you may need to include the -k flag, which allows curl to continue with the request even if it can't validate the SSL certificate that NetWitness presents. If you would prefer to use fully validated certificate chains, Josh has a video on setting that up. Next, we need to pass in the user credentials. If you're using these credentials in scripts, they'll probably be in plain text, which is why creating the service user with only the necessary roles is important. As far as the special characters and passwords go, some need to be escaped with backslashes, or many can simply be wrapped in single quotes, but passwords containing single or double quotes will need to be outside of a quoted string in order to escape them properly. If you don't want to type the password in the command itself, you could also use the netrc option with curl. An entry in this file would contain the server you're connecting to, the username, and the password. No characters need to be escaped. With that set up, you could issue your command with the netrc option as shown here. After the user is the target URL, and this whole string is enclosed in a set of quotes. It starts off with HTTPS and the host of interest with its respective API port. Then we specify the SDK command and include a couple important parameters. The force content type parameter can be used to change how the returned data is displayed. Two common content types are text plain and application JSON. You can see that each line of the text plain output matches one item in the JSON output. If you are working with JSON in a Linux environment, I'd highly recommend learning the JQ utility. This tool will allow you to interact with the JSON object in a proper object-oriented fashion by interpreting the data as a data structure. You could choose to include or exclude specific elements, perform actions on certain fields, or, most commonly, simply turn the JSON blob into a format with proper indentation and highlighting. After the output format, we have the size parameter. In the SDK values call, size will limit the number of rows that are returned. In the SDK query call, size does that too, but it can also act more as the size of the dataset that will be evaluated and then distilled down into the results in the format that you requested. We'll talk more about those situations later. There is an alternative to the size parameter called stream limit, which can be used in some calls. You can think of size as a single row of data, whereas stream limit defines a group of data. A group in this context is essentially a set of metadata to be collected from a single network session. So, this query would return all of the pairs of direction and alias IP meta values within 3 sessions. Pretend that our DNS traffic looked like this, where one session could have up to 3 different alias IP values. If we issue the query with a size of 3, you would see that only 3 items are returned. This is why it's important to understand how the query results are returned, because a row in this case is not like a row in a table. It's a row in the way a query returns data. A stream limit of 3, on the other hand, provided all of the requested metadata within 3 sessions without caring how many individual rows of data there were. There is a caveat to stream limit though. You can't use it if one of your select clause parameters is an aggregation, for example, count medium. In that case, you would either use size or leave off size and stream limit entirely. But again, remember that size is best used when the query will have a predictable number of entries per session. To be honest, picking a correct size value when using aggregations can be hit or miss, so it's probably better to remember that if you're using aggregations, just leave off size and try not to run queries that would maybe return a massive amount of data. Take this query, for example, that will give us a count of the destination organizations in the time window. Since there are 2 items per group of results, our size has to be a multiple of 2. You'll see an error like this if you need to adjust the size. But the size also needs to be big enough to encompass the underlying dataset, so we'll get a similar error even with a size that's a multiple of 2. Some SDK commands will support other parameters, so if you're not getting the results you're hoping for, review the documentation for that specific command and experiment with those options. If any of this was confusing, don't worry, we'll be going over more examples soon, but let's quickly recap what we've gone through so far. We established that the Core Services API is for the broker, decoder, concentrator, and other core services, and the NetWitness API is for respond and endpoint services. We discussed how to set up user accounts and permissions. We prepared the tools that we need, Postman and curl. We introduced the format and some necessary parameters of an API call. And we described the difference between size and stream limit parameters. Now, we are getting into the core of a Core Services API call. I'd suggest reading the documentation when you get a chance, and there are a couple places you should look first. The overview section is worth reviewing, and it's short enough to get through quickly. For usage of the individual calls, look under the SDK node section. There are separate SDK node sections for broker, decoder, concentrator, and other services, but they should all be mostly the same for the main calls that we're talking about. If you still need more information, the manual section also has details and context worth looking at. The SDK commands will have some form of parameter that lets you select sessions of interest. For some calls, you'll be explicitly passing in those session IDs. For others, you'd pass in a query or other selection criteria. This example here is an SDK packets call. You'll notice some %signs followed by numbers, which indicates URL encoding. Certain special characters in portions of the call need to be formatted in this way, and it's important to handle these correctly in your scripts. Technically, it's best practice to encode all non-alphanumeric characters in the value portion of a parameter. Spaces are mandatory to encode and can be represented by either %20 or a plus sign. But for the purpose of legibility though, spaces, single quotes, and ampersands are primarily what need to be escaped. If you run a command and get a 400, 401, or other error in return, or data that doesn't seem to match your criteria, there may be additional characters that you need to encode or escape. You could also quickly check varlog secure to make sure it's not actually an access issue. It can be confusing to decipher a URL encoded query, so you may want to use a tool like CyberChef to decode it. Just apply the URL decode recipe, and you'll see a nicely formatted query, but keep in mind that if you apply the URL encode recipe, it doesn't really do a great job of identifying the characters that need to be converted. This is partially because our commands only expect the encoding at the select or where clause and after those. Not only that, there are simply some non-alphanumeric characters that don't need to be encoded in these calls. With encoding out of the way, we can talk about the specifics of the different SDK commands and the situations that require using each call. There are 5 main commands that you are likely to need. SDK packets, which is used to render the results of a query as raw logs or a PCAP. SDK content, which is another way of rendering data, but can also extract file hashes, files, or text from a plaintext session. SDK query, which is often used to get session IDs, perform aggregation queries, or generally retrieve raw meta in a structured way. SDK values, which can fairly quickly return results of a single meta key from a query, and SDK session, which can return the start and end meta IDs for a given list of sequential sessions. This command might not be all that useful for small queries, but can help speed up some larger ones. Looking at SDK packets first, this command can accept either a query or a specific list of session IDs. You might use this when you know that all you want out of a query is a PCAP. Or you could also render raw logs in JSON or CSV format. I've seen this often in use cases where raw query results need to be handed off to a third-party vendor, attached to an external incident management program, or when the data needs to be ingested into a separate analysis pipeline. An important point to be aware of, though, is that when you use the time parameter, you should be providing that time in UTC. Next, we have the SDK content call, which is similar to SDK packets, but can render additional content types. When you browse NetWitness as an analyst, the UI shows you files, file hashes, text, and more. The reason that this call is useful is because many of those content types are not registered in metadata. For example, when you open a network session and look at the file list, the UI displays a file hash, but that is generated in real time as you open sessions. It is not stored in meta, and therefore you can't query for it. Another option including files is to render all of them from a query or time window, and then feed them into a third-party sandboxing tool. A similar option would be to extract the entire PCAP and use a tool like Tshark to extract the files, but that adds more overhead. One limitation of the SDK content call is that it only takes a single session as an argument, so I'm going to take a quick detour here and also call out the option of using NWConsole and its content method. NWConsole is a terminal application which is mostly designed for humans to interact with, though. One of its features is the content command, which can render and display data in a way that is a little more flexible than the SDK commands. But, under the hood, it's actually performing multiple different calls, so although it might be harder to incorporate into automation, I wanted to make a note of it in case it fits into your use case better. That's all I have to say about it in this video, though, but you can read the documentation to find out more. Moving on is SDK query. This is probably the most widely used call in automated use cases because it behaves similar to a reporting engine report, and by that I mean that you can pass in a select clause to define which meta keys get returned, a where clause to filter your results, and optionally sorting or aggregation settings. While this is a very useful SDK command, the additional flexibility does come at the cost of complexity, so we're going to have to spend a little more time talking about this one. Perhaps the most important concept to know when it comes to SDK query is the concept of aggregation. For example, imagine that you want to know how many connections are being made to IP addresses associated with certain destination organizations. A query with no aggregation would return results that look like this. Each line is a separate session, so in a real-world query, there would actually be hundreds of thousands of results here. Well, what if we only want to see the unique pairs? We can do that with the group by clause, but when we talk about group by, we also need to understand how the select clause works. The most common goal for running this query is to produce a table that includes a count of how many times a certain meta or pairs of meta occur within a dataset. To do that, we need to use an aggregation function, specifically the count aggregation function. We also need to pass in which meta key we want to count, which is most often the medium meta key. And when using this function, it will usually be the only item in the select clause, but you technically could also include other aggregations here. But any individual keys that you want in the results should go in the group by clause. This might be confusing because when you run queries without aggregation, if you want a key to show up in your results, you'd include it in the select clause. But with aggregation, try to remember that your count should go in the select clause and that the components should go in the group by clause. If that wasn't confusing enough, here's another situation for you. Sometimes you might want results that aggregate data without a count, in which case you would need to use the nothing aggregation, usually with the session ID meta key passed in. This nothing session ID is needed because we can't leave the select clause blank, and the way we tell the engine that we want results to be grouped by combinations of meta values is with the group by clause. Most of the time you'd actually want a count associated with each pair too, so you don't need to worry too much about this. So if we modify our query and include the count medium aggregation, you will see that this is a lot more helpful for understanding the traffic matching our query. The medium key indicates whether the session is a log or a packet session, and since we know that all of our sessions must contain this meta, a count of medium is a good way to aggregate our results. We also added an order by clause to sort by a descending count. Taking a minute to review a decoded call, again we're using curl, ignoring insecure certificates, and passing in credentials. This example issues a call specifically to a broker, but you could issue this call to the downstream concentrator if there is only one that holds the data you want, and you'd get the same results. One exception is when you are querying based on session IDs, which are unique to each device. In other words, when a session enters a decoder, the decoder tracks it with its own ID. When a concentrator aggregates that session, it tracks that with a different ID. And when the broker aggregates sessions, it again tracks those with a unique ID. This could come into play if your use case involves following up from a respond incident where the alert contains the session IDs of the concentrator that provided the data to ESA. We'll talk more about that later. After the port, we have the SDK command and the content format that we want the data returned in. We can then choose whether to use size or stream limit to control how many results are returned depending on the query we're running. Queries that use aggregation can't use stream limit, and if you try, you will just receive an error, which is easy enough to recognize and correct. You might also get an error if you try to use a size that is incompatible with the number of rows that you are requesting. And in some cases with aggregation, your size will need to be large enough to encompass a certain portion of the result set, but this can be difficult to predict. This is one reason that the documentation actually suggests omitting size when using group by. This would allow all of the results to be returned, which might be okay as long as you are sure that the dataset will be a manageable size. Then, our query contains a select clause, where clause, group by clause, and an order by clause. Again, this is all submitted with URL encoding, and if you are getting 400 or 401 errors when testing your calls, double check that you haven't missed a space or other character that needs encoding. Here's a closer look at the results in the text plain content type, with highlighting to make it easier to see the different result groups. And here's that same result set in the application JSON format. In both cases, we see that the group field ties these results together. Next up, we have SDK values, which you would use to return all of the meta for a single key. The results are automatically aggregated by count, and by default are sorted in alphabetically descending order. This call is the same process that the UI uses to display values when you open a meta key. The field name parameter is how you specify which key to get the values for, and you can filter down the results by passing in a where clause, which is the same concept as we described for other calls. You can also pass in a size to limit how many rows are returned, but there is no stream limit parameter because it's not applicable to how SDK values works in terms of grouping. In this example, we've said that we want to see data in the plain text format. We're aggregating and sorting by session count. We want to see a max of 10 entries returned, and we see that we are looking for values in the org.dst meta key. We also have a where clause in the same format that we used for SDK query. If you look through the documentation on this call, one parameter that you might be tempted to use is the threshold parameter. In theory, this can tell the engine that once a value has reached the threshold, it can stop counting and just move on. This does make the call more efficient, but I found that it can produce undesirable results in the way that it handles approximations. So if you do have long-running queries that need to be tuned, make sure you study the effects of this parameter before you use it. Similarly, you could use the aggregation function and aggregation field name parameters, or some of the other parameters listed in the documentation to optimize your query, but for the most part, the basics that we've already covered will probably do most of what you need to do. Although, one exception might be to use the ID parameters instead of the where clause. Each meta value in the database is assigned an ID when the value is created during parsing, so session number 1 might have meta IDs 1 through 30. Session ID 2 might have 31 through 75, and so on. By passing in a start ID of 1 and an ending ID of 75, your query might run a little bit faster on those two sessions, rather than if you had to find them via the where clause. This brings us to SDK session, which I've seen used often as a follow-up to respond incidents. Although a recent version of NetWitness added a respond API call that reduces the need for SDK session, but we'll still cover both. The purpose of this call is to return the meta IDs for a provided session ID or range of session IDs. And again, since meta IDs are sequential, this command can only accept a single or sequential session IDs. A respond incident is comprised of alerts, and an alert is a collection of events. The word event here usually refers to a single session, though some complex ESA rules technically could function a little differently. But normally, one incident might have any number of non-sequential sessions bundled up inside any number of alerts. So, organizations might use a playbook to iterate through each alert, and again through each event to pull out those session IDs. From there, the session IDs could be used in a SDK values or SDK packet call for more analysis. Or, as we discussed, you could feed them into SDK session and collect the meta IDs, which might have better performance in some cases. At this point, you should be pretty well equipped to handle most cases involving the Core Services API. If nothing else, this extra context will make understanding the documentation easier, but I think you'll find that most of this will be somewhat intuitive as you start working with it more. If you aren't quite sure where to go from here, I'd suggest starting with SDK query. Make sure you can issue commands, practice URL encoding your queries, and experiment with the select, where, and group by clauses. Moving on, we're going to take a look at extracting data from respond, and although you could do this at the command line, I'd recommend doing your testing with the Postman tool before integrating the queries into your playbooks or other scripts. So, if you haven't already, download and install Postman. Make sure you sign up for their free account as well. You could, of course, use any other API development tool, but we already have a collection built using Postman. At the bottom of this blog post, you'll find that collection in a zip format, which you will need to unzip. Then, from Postman, import that JSON collection file, and you'll see most of the queries that you would need. As you can see, there are pre-built queries for the different APIs, not just respond. I do have two comments here, though. First is that there's technically a typo in the getRefreshToken call. it's using the access token variable when it should be using refresh token. Simply update this and save the change. Don't worry if you see an error that says this variable doesn't exist. If you look in the tests section, you'll see that the response will set these variables. Variables, by the way, apply to the whole collection, so another step you should take is to populate your environment info here, like your Node 0 address, your broker address, which in most cases is your Node 0 address, and credentials at the very least. The purpose of this getToken refresh token command is to renew an expired access token. Access tokens don't last as long as refresh tokens, and when you use a refresh token, it automatically renews the access token. In other words, you probably want to use refresh tokens most of the time unless you specifically want your access to expire after a certain period of time. An access token is valid for 8 hours, and a refresh token is valid for 30 days. The other comment is that this collection was built before one of the commands, the alert fetch command, was introduced, so we need to add that. It's actually a good opportunity to get familiar with how Postman works. Start by duplicating the respond get incident alerts query. Rename it to respond get alert fetch. If we look at the documentation for this call, we see that the URL path should be REST API alert fetch. In Postman, we see that this API variable is already REST API, which means we only need to add alert fetch here. Next, the documentation shows us that we need to pass certain information in the body. Copy this line from the example and paste it here. Then, let's modify the selection criteria. Using this _ID field will let us pass in an alert ID. We can leave this other parameter empty for now, but we'll talk about that soon. In this case, our body data is in JSON format, so we can keep this JSON setting here, and Postman will handle the proper header creation. That's all we need to do for now, so go ahead and click Save. Okay, let's take a step back for a moment. If you are learning the NetWitness API, it's a safe assumption that you either have data within NetWitness that you want to extract, or you have additional information that you want to use to enrich what's already in NetWitness. A simple workflow might look something like this. An ESA alert fires, which triggers the creation of an incident. An automation platform like XSOAR or NetWitness Orchestrator identifies the creation of the incident. This could be NetWitness pushing an alert via email or syslog, or the automation platform reaching out to check periodically. The incident kicks off a playbook, potentially with actions specific to the use case. These could include digging deeper into the meta associated with the individual alert events, drafting an email template for the SOC to use to notify affected users, gathering more details from other organization intel sources, pushing these details to a case management tool, and so forth. From there, analysts will perform their own tasks. When they're done, the NetWitness incident can be updated with information on the steps taken or other case status. With this in mind, your automation platform needs to have some form of credential management. This is where the authentication queries come into play. As a reminder, this API uses user accounts in the standard Security tab in the Admin Security page, and they need to be assigned to a role that has the Integration Server API access permission. The automation platform also needs to have a way to receive notifications that an incident has been created, or a method for routinely querying respond. On the incident notification page, you can define an email or syslog server. Keep in mind that some incidents are created when an alert comes in, then additional alerts for the next number of hours can also be bundled under that same alert, so your playbook should account for this. Once you have been notified, that notification should include the incident ID, which you can pass into the REST API incidents incident ID query. Or if you are manually fetching incidents, you might have a playbook that collects all incidents within a time frame, which would be the REST API incidents query. Or you might get them specifically by name, which would be with the incidents fetch command. In the case where you used incident fetch, you would then have a list of alert IDs to iterate through. To process them, you would use the alert fetch command. The alert fetch command, which was introduced in NetWitness version 12.2, can be used in a few different ways, but I think there is one main way that is usually implemented. In short, this command will look through a big JSON object of the events in an alert and return data based on your parameters. Typically, you would request that the API sends you back that whole JSON object, which you then process within the playbook. You can see our request here for meta name, meta value, number of records, and include fields, and is being sent as raw JSON. Meta here might be confusing if you are thinking in NetWitness terms, but it's really just referring to the keys of the JSON object. So, as I mentioned, we are taking incident IDs that we got from the incident fetch command and plugging it in. Then, this include fields option is what tells us to return the whole object for us to process ourselves. One important note, this alert fetch command had a bug in NetWitness version 12.3.1. Include fields equals null is the way to return the entire object, but that didn't work in 12.3.1. There was a workaround though, which was to pass in original alert, which still returned an object with all of the events but excluded some of the header info. If you are already on 12.4 or any pre-12.3.1 version, use null here. If you are on 12.3.1, just use original alert for now, and consider switching to null later if you need that extra info in the results. Let's take a quick look at those JSON objects. Side by side, we can see that the result when using include fields equals null has more information, but probably not much that's going to inconvenience you. Inside of the original alert object, you have the alert name under the module key here. Then, under that, for each event or session, you have the session ID, the remote ID, which is the session ID from the device that captured the event source ID, which is the device that aggregated the session from the remote device, and the DID, which tells you what the source decoder was. In some versions of NetWitness, this event source ID may be in this unique ID format rather than in a hostname or IP format. In that case, you might need to have a lookup table in your playbook to translate those IDs into hostnames or IPs. To do that, you would go to the command line of your admin server and run orchestration CLI client-L. So, now you know how to gather all of the meta for a session that was involved in an incident. You can use all of that meta in your playbooks however you see fit. Converting this call used in Postman to something that works in your playbook should be fairly straightforward. On the right-hand side here, there's a code snippet icon, and when you open it up, you have lots of choices including curl, wget, Python, and so forth. To quickly recap this last section, you would use the NetWitness API if you wanted to collect incident or alert data from Respond, which is often associated with automated playbooks. Setup requires creating a user account for access, and if you follow our recommendation to test with Postman, you should also make an account with them and install and configure that software too. The first call to the API should be to retrieve the tokens, after which point you would include the access or refresh token in your calls. Then, most likely, you would be getting a list of incident IDs, which each contain a list of alert IDs. Then you would iterate through those alerts, which are collections of sessions referred to as events. And each of those events have the raw metadata that you are presumably gathering in order to take some kind of action in the playbook. I think we have covered a lot of ground here today, so let's quickly summarize the Core Services API too. Again, This is how you issue queries against the core NetWitness database. To do that, you'd need to have the accounts created on each service that the queries will target, which most likely will be the broker and possibly concentrators or decoders too. There are several different commands that you can use for these queries, and SDK query might be a good starting place if you are still getting familiar with this process. Once you've picked the command to run, pay special attention to encoding special characters in those commands, and also get familiar with the format that data is returned in. So once you have the Core Services API under your belt, you'll be able to extract metadata, generate PCAPs, render files, and more. Combine that with your Respond API capability, and I think you'll be well positioned to automate many analytical tasks such as archiving PCAPs for compliance requirements during incidents, submitting files for external sandboxing, and tracking and streamlining response to common use cases like plaintext credential reuse, policy violations, or abnormal traffic patterns. Even if you don't have a specific use case in mind yet, hopefully you can see how having programmatic access to raw data can be a valuable tool. That's the end of this video though. Let me know if you have any questions or feedback. Thanks again for watching.